When you add together an acid and a base, they're going to neutralize each other. So we have what we call a neutralization reaction. And whenever that process takes place, we're going to be forming both a salt and water as our two products. And in chemistry, a salt will be any ionic substance, which means that it's made up of metal and nonmetal elements from both sides of that staircase that divides our periodic table. So a salt is any ionic substance, specifically the one that's formed during an acid-base neutralization reaction. And we have some steps here for how to complete one of these reactions. First thing we want to do is label each reactant as either an acid or a base. So HCl we know is going to be our acid, and NaOH is going to be our base. And then we want to circle what makes it an acid, which will be the H, or what makes it a base, which will be the OH, the hydroxide. So we're going to circle the H on the acid and the OH on the base. And at this point, we're going to go away from our rules just a little bit because it'll make things a little bit easier in the long run if we will go ahead at this point and make sure that H and OH are equal. We have equal amounts. So you need to check to make sure H is the same as OH. And if it's not, then we're going to add coefficients, big numbers in front, to make them equal. That's going to help us figure out how everything's going to come together and eliminate our need for balancing at the end. So I have one H and I have one OH. They're the same. So the two circled parts then are going to come together to make water. And typically we'll write water as our second product here. The first product will be formed from the other parts of the reactants. They will come together to make the salt, our other product. We always write the positive ion first. And we won't actually have to do step B as long as we make sure H and OH are equal at the beginning. And we'll also not have to follow step 5. So we're going to have chlorine and sodium that are going to come together here. We write the positive ion first, which is going to be our metal. So that's going to be NaCl, and we have just one of them. If we wrote any coefficients out front, we would use those to help us figure out charges, but there's no need on this one. We already had one of each. So let's try another one. This ends with OH, so that means this thing here is going to be our base. This one starts with H, so that's going to be our acid. Those two parts are equal. There's one of each. So they're going to come together and make water. The other parts that are left behind, we've got K and we've got ClO4. So those two will have to pair up. We write the positive metal first, the thing that's to the left of our staircase. So that's going to be the potassium. And then we've got the chlorate, ClO4, perchlorate. Okay. CaOH2, think about it, is that an acid or a base? It's got OH here, so that's going to be a base. HI starts with an H, so that's going to be an acid. Look at them and make sure they're equal. We have two OHs, but only one H. So our rules that we kind of adapted up here say that we're going to add coefficients to make them equal if they're not. So we're going to put a 2 in front of HI here in order to make sure the H's and OH's can all pair up. And in this case, since we have 2 of each, that means we're going to make 2 water molecules out of it. Because for every OH and every H that come together, we'll make a water. So since we have 2 of each, we're going to make 2 water molecules. Okay. So then let's see what we have left behind. We've got calcium here, And we've got iodine here, but you have to pay attention to the fact that when we put the 2 as a coefficient out front, it means we're going to have 2 of everything there. So it's not just 2 hydrogens, we also now have 2 iodines. So we'll write our metal first. Calcium is the metal. We have 1 of them. And then iodine is our nonmetal, and we have 2 of those. H2SO4 starts with hydrogen. It's our acid. Reacting with lithium hydroxide, the OH indicates it's a base. We have 2 hydrogens, but only 1 hydroxide. So we put a 2 in front of lithium hydroxide to make sure we have equal amounts, and we're going to make 2 water molecules when these things pair up. And then we look and see what we have left behind. We have SO4, and we have 2 lithiums. So we list our metal first, which will be lithium. We have 2 of them. We cannot write the 2 in front like this because everything else that we wrote would be multiplied by 2. We just want to say we have 2 lithiums. So we'll put Li with a 2 as a subscript, and then we've got SO4 to combine with it. We've got barium hydroxide. The OH indicates it's a base. We've got phosphoric acid. The hydrogen here at the front indicates that it's an acid. And you'll notice we have 2 hydroxides and 3 hydrogens. So anytime we have 2 and 3, remember we're going to have to make both of them equal to 6. That's the least common denominator. So think about, what do I need to multiply 2 by in order to get 6? I have to multiply it by 3. And then what do I have to multiply 3 by in order to get 6? I have to multiply it by 2. So in writing those coefficients out front, we have 6 hydroxides and 6 hydrogens, so they're going to come together to make 6 water molecules. And whenever we do that, we're going to have 3 bariums left over here. And we're going to have 2 phosphates left behind. So barium is our metal, so we'll write it first. Remember, we're going to use the subscripts to show that we have 3 bariums. And then phosphate, PO4, is a polyatomic ion. We have to keep it together. But we have to show that we have 2 of them. So we put it in parentheses and put the 2 after. The next little bit is not going to be on your worksheet, but it does have some information that's kind of interesting. When we are trying to find the concentration of an acid or a base where we don't know what the concentration is, we have to figure it out, we use a process called titration. And you have to use a solution that you do know the concentration of in order to determine it. And you're trying to carry out a neutralization reaction, and whenever you reach the point where it has been neutralized, where you have an equivalent amount of acid and a base, that's either called the end point or the equivalence point. And the equivalence point can be determined by either using a pH meter, an electronic device that kind of shows you on a display what the pH value is, or by watching the color of an indicator. You're looking for a change in that indicator. And indicators are things that will change color depending on if it's an acid or a base at different pH values. And the most commonly used indicator in titrations is phenolphthalein, which we saw before, and we know that it's colorless in an acidic solution, but if it's in a basic solution, it turns a hot pink or magenta color. So we have an example here of what a titration would look like, the setup for it. You have a burette up at the top that's going to contain either an acid or a base that you do know the concentration of. There's a stopcock here that allows you to have it closed or open depending on which way it's going to be turned. And then down here you're going to have your acid or base, whichever one was not in the burette, and you're going to have your indicator there. Usually it's phenolphthalein. And you put a known amount into your pipette that you put into your burette, then you have your initial volume reading, you know how much you start with. And then we have our unknown solution down here at the bottom. And you turn the little stopcock right here, and then you let the liquid drip down until you see a color change. Whenever that color changes, that's whenever you've neutralized the solution. It goes from being acidic to slightly basic whenever it turns that pink color with the phenolphthalein. And we can see the final volume reading. And then we can figure out from those values what the concentration of that unknown solution was. And you can kind of see here what it looks like. You can see the little thing that you turn so that you can open or close it. So this was our unknown acidic solution here at the beginning in the first picture. In the second picture, you can start to see a kind of swirl of pink. So it's getting very close to being neutralized at that point. And then whenever it's a light pink color is whenever you've achieved neutralization. If it gets to be a bright pink color, like we see here, then you have too much. Your equivalence point is right there in the middle of those two shades. So on your assignment today, you don't have to do anything with titrations. We have to classify substances as either acids, bases, or salts, which salts are going to be your ionic compounds made of metal and nonmetal. Bases are going to end with OH. Acids are going to start with H. And then we'll write some equations for our neutralization reactions. So if we look in this first column, number 1 ends with OH. So when it ends with OH, it's a base. Okay. Number 9 here at the end starts with an H, so we know it's an acid. Okay. And then number 7 is made up of a metal and non-metal. It doesn't start with H, it doesn't end with OH, so that's going to be a salt, an ionic compound. There are a few exceptions here, so be careful on number 8 and number 4. If you're not sure what those are, be sure that you look them up. They are kind of exceptions. Okay. Just to kind of refresh your memory here, we're going to label these as either an acid or a base, depending on what it is. We're going to circle what makes it a base, what makes it an acid. Make sure you have equal amounts of them. That will then tell you how many waters we're going to form. And then the other parts that are left behind will come together to make the other product. Be sure that you're writing the metal first. If you have something like number 2 here, where the number of hydroxides does not match the number of hydrogens, you use a coefficient out front to make sure they are equal, and then that will tell you how many waters we're forming. And it will also help us know how much of what's left behind will come together to make the other product. We have 2 potassiums paired up with the sulfate.